Section 3.4, we're going to talk about comparing measures of center. Sometimes it's better to use the mean, other times it's better to use the median. Okay, so if the distribution is mound-shaped, fairly symmetric, even like what we call a normal-shaped curve, which we'll talk about in Chapter 6, you can get by with just talking about the mean and the standard deviation to describe the center and the spread. Okay, remember measure of center, you'd either use the mean or the median, and for measure of spread, you would use either the standard deviation or the interquartile range. Okay, so if it's a symmetric mound-shaped distribution, a lot of times the mean and standard deviation is the two values you would use to describe it for its center and spread. Okay, if it's skewed left or right, or even if it has an outlier, it might be pretty symmetric except for one value that's an outlier, you're better off using the median for the measure of center and interquartile range for the measure of spread. Okay, if it's not unimodal, which we'll talk about, we'll show you some graphs in this section that aren't unimodal, so they might be bimodal. In other words, they have two values that are occurring a lot that aren't close to each other. Sometimes it's better to split the data first. Okay, so let's look at this graph of song lengths. Okay, and you notice I have quite a few song lengths that are fairly short, maybe just a little over 200 seconds. Okay, but I do have some that are much longer, and you guys probably can even think of those. Same, maybe a song such as Stairway to Heaven or something of that sort. Okay, so in this case, it was much better to use the median because it's not affected by this long tail on the right of the song lengths. Okay, so in this case, I would describe a typical value or the center of the distribution of song lengths using the median, okay, which is about 226 seconds. Looking at the San Francisco temperatures, well, San Francisco doesn't have a lot of variability in its temperatures, and you get a pretty mound-shaped distribution. So in this case, the median and the mean are very close to the same value. So in this case, a lot of times we use the mean. If you do use the median, it's not going to make a big difference. Just if you're going to do a lot more advanced statistics with it, the mean is actually easier to work with. That's why if we can use the mean, we do. Okay, so in this case, either one works, but again, the mean is what most people are more familiar with than the median. Okay, so let's look at what happens when you have an outlier to the mean and the median. So there's several businesses on Main Street, and that's the number of employees that each business has. Okay, so there's 7 businesses. So let's say that if the business that employs 26 people, you notice it's the largest value, if it closes and some big box store such as Walmart or Kmart or something of that sort replaces it. Okay, so now if I do that, here's going to be my list of numbers. The 26 becomes this very large number at like 334. Up here you notice my mean and my median are both very close together. Okay, so now what's going to happen to my mean and my median when this big store that employs lots of employees moves in? Well, the median, if you notice, actually stays the same. It's still at 18, okay, but the mean became much larger at 61. That's because the way you calculate a mean is by adding them all up. Instead of only adding a 26, you're now adding a 334. You notice the mean is not really a typical number of employees that these businesses are employing, because there's only one store that even employs more than 61. All the other stores employ quite a few less. So in this case, it's the median you want to use to use as the center of the distribution or a typical value. But just adding that one value in made my mean change by quite a bit. Okay, you notice it didn't change my median at all. Okay, so what it's affected by outliers? Well, the mean, the standard deviation, and the range. So if you have an outlier or even skewed distribution, those 3 values will be affected. It's better not to use them to describe the distribution. Instead, it's better to use the median and the interquartile range because they're not affected by outliers. Okay, so now you can construct a data sets, and there's actually 5 of them here. And just give an example, so pause the video and see if you can construct data sets for each of these different situations. When you get done, you should have 5 of them. Pause it, go ahead and do it, and then come back and play it because I'm going to talk about these different ones. So go ahead and pause the video now. Okay, so for the first one, your distribution should have been fairly symmetric to get the mean. I'm sorry, this is the mode. I was talking about the next, actually the third one, your distribution will be fairly symmetric where the mean and the median are equal. Okay, you want the mode and the median to be equal. So in this case, you just have to have your highest value at the same place where your median ends up being. Won't necessarily have to be symmetric or anything. Okay. Okay. Again, the mode is the value that occurs most often. Okay. So for the mode to be greater, you're going to have at one number a large stack of dots if you're making a dot plot, and it's greater than the median, so you're going to have quite a few values less than it. Okay, so you can actually have your maximum value be the mode and just make sure all the other values are less than it, and that works. Okay, we talked about the mean and median are equal, and that's where you're going to get a fairly symmetric distribution. If the mean is greater than the median, your distribution is going to be skewed to the right, or else have a high outlier. If the mean, you don't have to do this one, but if you did, if the mean is less than the median, then your distribution would be skewed to the left, or else you would have a low outlier. Okay, and if they're all equal, the mean, the median, and the mode, it's also going to be a fairly symmetric distribution. Okay, let's look at some bimodal distributions. Okay, and usually in a bimodal distribution, neither the mean or the median will represent typical values. And most of the time we're going to end up trying to split these into two separate categories and just looking at both distributions separately. Okay, so this is restaurant receipts per person at a restaurant. Okay, and you notice I definitely have two distinct clusters. The mean definitely is not a typical value because the mean ends up falling between the two clusters, and there's no receipt that was even close to where the mean falls. The median falls towards the right edge values of the lower cluster. So even that is not really a typical value. Okay, so what should we do? Well, there's probably a reason we get two clusters. In this case, it's because I have both lunch and dinner customers. So this lower cluster is probably for lunch, and this upper cluster up here is for dinners. So let's look at the two distributions separately instead of together. Okay. Now you notice the lunch receipts, the graph on the left, is fairly symmetric, or a mound-shaped distribution. But my dinner receipts is definitely skewed to the right because I have several people who spent quite a bit on their dinner. So I have these outliers up on the right side, on the high end. Okay. Now, for the lunch receipts, it looks like I could use either the median or the mean, and I'd get about the same answer. But for the dinner receipts, I definitely want to use the median as a typical value, or the center of this distribution, because the mean is up too high and I don't have as many up at that end. It's not really a typical value. Okay, so one thing to remember is you should never compare a median to a mean, because if you look for dinner receipts, remember we want to describe the middle with a median, and for the lunch receipts it would be okay to use the mean, but we don't ever want to compare a median of one distribution with the mean of the other. So in this case, since we're trying to compare, you would want to use the median for both of them. So the lunch median is about $8, and the dinner median is about $22. My arrow's not pointing quite to 8, but it should be over here at 8. Okay, so that's the end of chapter 3. So if you have any questions, again, don't hesitate to email me or call me on my office number. Not a big deal when I'm in. I'll easily answer, or I will get back to you as soon as possible.